Right, everybody. Welcome. Thank you for joining us. Really excited to be back in Toronto and kicking off another DevOps Toronto with David Espejo. Did I get that right, David?
That will be like Espejo, like H-O.
Espejo?
Yeah.
Got it.
Right.
Okay. I'll try it again when I hand over the mic.
Thank you for asking.
Of course, I have to ask live when I'm being recorded, but I always test in production. Okay, so thanks everybody for joining us. I've got a couple of quick messages before I hand things over to David. First of all, we have excellent sponsors, DevOps Toronto, that make all this possible and really make it easier to run the meetup, manage everything that goes into getting this off the ground and keeping it running. So CloudBees has been with us for quite some time. BMC as well, another big player in the market. If you're not familiar with CloudBees or BMC, or our longest sponsor, JFrog, you should definitely check them out. They really are sort of end-to-end, big picture DevOps software tooling organizations and providers. And if you've got multiple tool chains, if you've got complex environment, then using a large-scale production grade tool chain can really make a difference. So check them out. And I want to say thanks to them for helping us put this on and keep it running. So I've got a couple people coming into the waiting room still. I will continue to let people in. As you join, let us know where you're from in the chat. With that, I am going to hand over the mic to David. David is going to be talking about choreography. I think this idea of choreography is really interesting. You know, it seems like everyone has just started to get comfortable with the idea of orchestration and observability and some of the more advanced subjects in the DevOps ecosystem, and grappling this challenge of like keeping everything coordinated and understanding all of the moving pieces that go into software delivery and operations. And that scope and complexity just keeps expanding. So ideas like choreography, doing this complex operations very well involves coordinating a lot of things and understanding where things are and how they work together. So very interested to hear about this from David. David's joining us from VMware, and he's joining us physically from Colombia, where he constantly battles electrical storms. If you've never heard of this is news to me, but he's joining us from a town called, actually it might be a city, I don't know what the size is. I should know. Ferrera, Colombia, which I, of course, do not pronounce properly because I've never known how to pronounce my name properly. But with that, I will hand it off to David. I'm going to stop presenting and let him jump on here and take it away.
Ooh, awesome. Thank you, Steve. And yeah, it will be Pereira, something like that. It's fine. All right. Yeah, well, welcome everyone. We're really glad to be here in this meetup, a community we've been following for quite some time, and just wondering when will be the time to actually be here sharing with you. So thank you for having me. David Espejo, I work at VMware as an open source community manager. What does an OSS community manager does? Well, the role is all about handling some of the non-code duties that an open source project requires to be successful. So opening and maintaining communication channels with users, contributors, maintainers, and also helping with processes and tools to actually have a growing and healthy community. I'm based in Colombia, and well, I'm joined today here in the session by Rashid and Emily. Thank you for being here. They are part of the maintainers team. And yeah, I'm really glad that you are here and you will be able to cover me with the deep technical questions. So if part of the people who build the code is here, you are assured that you can ask the tough questions, no problem. All right, so in this session, I will try to describe briefly some of the framework or the ideas that are behind the project, some of the challenges we have identified in software delivery. Then we will introduce a pattern to try to address these problems. We will see how it's implemented in the Cartographer project. I will go to a brief demo, and then we'll wrap up and we'll have a Q&A section, but feel free to ask your questions. Okay, so I'll try to start with why. Well, according to the authors of this, thank you, Emily, of this seminal book on the field of continuous delivery, well, the most important problem we face as software professionals is this: how to take a new application version, a new idea, a new commit into the hands of users as quickly as possible. That's it. This book was published like 11 years ago. So if you go fast forward into the future to the definition for the cloud native term provided by Joe Bida, Kubernetes co-founder, in my opinion, this definition has an implicit recognition for the same set of problems, because cloud native is basically all the technology, teams, processes, etc., necessary to manage complexity and to tackle a problem of lack of speed, lack of velocity in software delivery. So the core problem remains the same. Traditionally, what we have done so far is to try to address this challenge of getting source code to production using a pattern that it's called the pipeline, right? The delivery pipeline. So in this pattern, we have a set of steps necessary to take your code to production. And there are several features here. First, most likely, each one of these steps is executed by a different tool, right? So it introduces complexity by definition, because each tool has different inputs, different outputs. So in an attempt to try to coordinate the flow of information, the flow of execution from different moving pieces, we wire them together in this pipeline pattern, which is a sequential step-by-step execution flow. And in order to coordinate the passing of information between tools, between steps in the pipeline, we rely on a central entity that follows a pattern known as orchestrator, or the orchestration pattern. So in this orchestration pattern, there is a dependency, there is a very close relationship between each one of the steps required in the pipeline and the central orchestrator. So it introduces tight coupling, because the orchestrator is there not only to coordinate the passing of information, but to also deal with the actual implementation of each one of the steps. So if, for example, you want to use for a workload, you want to change the tool you use for building the image, you would have to change the actual code or the configuration in the orchestrator, right? So it necessarily introduces this tight coupling, this close relationship with where the pipeline, the steps, and the relationships are codified in the orchestrator. So tight coupling is an enemy for change in distributed systems. It's one of the drawbacks here of this pattern. It, by definition, it makes it difficult to swap tools because, as I mentioned, if the logic is already there in the orchestrator and you want to change one of the tools or create a pipeline that has different steps, you will have to change the logic for that in the orchestrator. And also, it produces rigid workflows. I mean, the execution is linear. It's harder to implement, for example, parallel execution of tasks. And what if, for example, I want the pipeline to be triggered by something other than a new commit? In this specific example, the first step is watching like a repo, a Git repo, and every time there's a new commit, well, the pipeline will be executed. But what if, for example, in the security scan, there's a new CV discovered? I would like to avoid having to submit an artificial commit for the orchestrator to trigger the pipeline. So that becomes harder to do in this scenario, in this pattern. And that's only for a single pipeline, for a single workload. For example, that was a workload, running on the Rails framework, and it's managed by dev team number one. But what if you have a different team that will most likely will have a different pipeline design and different kind of workload? So probably they would like to use a different tool for the third step, for building the image. They don't want to use, I don't know, KPack, they want to use Scanic, for example. So someone will have to codify that logic in the orchestrator, and so on and so forth. If you have a different team with a different workload and completely different pipeline design, again, someone will have to codify that in the orchestrator, increasing the dependency on this central entity. So that basically produces an inconsistent path to production, because in this ocean, in this universe of different pipeline designs, imagine that now the organization wants to standardize on a different tool for security scan of the source code. You will have to change that logic in all the pipelines throughout the fleet of application. So it becomes harder to maintain. Also, there's no clear separation of concerns, because imagine that in this context, something fails. There's a problem. So most likely devs will end up chasing the root cause of an issue, probably doing DevOps or operations stuff instead of actually writing code. That's one potential problem here. In general, the higher operational load. Every time there's complexity involved in a system, the cost to manage it increases exponentially. There's science backing that sentence. So that's kind of the scenario that we have saw with orchestration and software pipelines so far. So now the introduction of a pattern that is more familiar to the event-driven architecture, the choreography pattern. Here it has some, it has a interesting contrast with the orchestration pattern. So let's think on the words. In an orchestra, there's every musician, they know how to actually play the musical work they plan to play. They know how to do it, but even with that, they rely on a central conductor who actually manage the flow of notes and information between all the instruments. In a dance team, in a choreography team, once they are in the scenario and the music starts to play, each one of them, they know what to do. And they are, for the most part, they are autonomous. And if someone else in the dance team fails, the rest of the team most likely will be able to continue, and they will know what to do. So bear that in mind, because the choreography pattern has some implications from this difference between an orchestra and a dance company. Okay, so what is this resource? This is the first time I introduce the term resource, and this is a step in your pipeline or in your software supply chain, right? It's just a step necessary to get your code to production. We call it, I mean, the Cartographer project call it resource because it could be several things. It could be a container image. It could be a config map in the Kubernetes cluster. It could be several things necessary to get your code to production. So we have this resource, and we only know a couple of things about this. First, we know that it has a single input, right? Input type yellow, input value X. And with that, it will produce output type yellow, output value X. That's it. It's a black box, let's say. I mean, we don't know anything about how it produces this output, and we don't care at this point. We really don't care. Doesn't matter. The another thing we know is that if we put a different input value, it will most likely produce a different output value. Pretty simple, right? What if this is a self-mutating resource? So, for example, we have here image builder. I don't know, KPack. There is no new commit. There is no changes in the container image, but the base OS has a new revision. It's a new version. So there's a change that could be detected here, and it will produce a new output value even when there are no new inputs. So in this specific case, or a different example, what if this resource is a GitOps agent watching a repo? And you don't have, you're watching a repo URL and a branch, and that's it. There are not big changes there, but probably there's a new commit that was produced by a different tool. The inputs doesn't change. I mean, the URL path and the branch doesn't change, but there's a new commit. The resource is a self-mutating resource that will be detected and will produce a new output. So that starts to reduce the load, the actual work that devs or ops team need to do to codify that logic to be able to detect that kind of changes, right? And it also helps, this pattern, it also helps with flexibility, or it makes it more flexible. There's another word for that, but I just forgot it. Because if you're using, for example, again, KPack to build the image, and the output will be the path to the image, that's it. If you use another tool for that task, for example, Canico, most likely the output type will be the same, will be path to the image. So as long as the output type is the same, you can hot swap tools without changing the logic, without changing anything else. So it's a completely opposite approach to what we were looking at in the orchestration pattern. So this is resource A, let's say step one in the supply chain. What happens with the next step? Well, the only thing the next step or the next resource will do is to actually watch. It will be watching a specific output, a specific output type. And whenever a new output is produced, he will know what to do. He will know what to do next. All right, that's the summary. And we have an underlying platform, in our case, a Kubernetes platform. So all these sounds great, but we need something else. We are lacking something in the middle layer that will actually reconcile what is desired state, because all that we see here at the top, it's declarative. It's a completely declarative approach. Here's what I desire. What I envision are the steps in my supply chain. Here are the inputs, the relevant outputs, and the order of steps, and that's it. This is declared state. But the actual state needs to be reconciled by someone. Someone needs to be able to observe this and make it real. Who is that layer? Well, we need a choreographer, and that's basically introducing Cartographer. Supply chain choreographer for Kubernetes. Cartographer is a project that was recently added to the CNCF landscape in the continuous integration and delivery subcategory. And the goal here is that we will have the same steps in the supply chain, right? I mean, the goal is not to affect the way organizations design their path to production, but just to improve it. So the first thing that the choreography pattern implemented by Cartographer does is to remove the dependency on a central entity, right? And second thing is to actually wrap around each one of the steps in a common abstraction called a template, right? And this is important because science has already demonstrated that the only thing you can do with complexity is to hide it, to put an abstraction layer on top of it to be able to manage that. You just cannot remove complexity. You just move it to a different place. In this case, we're wrapping around each one of the steps in a common abstraction. And with that, we will get a consistent interface between resources or between steps in the supply chain. A consistent resource will help a lot on unlocking flexibility, repeatability, as we will see later on. Okay, so we wrap around all the steps in a template abstraction, and then we wire them together using the choreography pattern that we just saw. Resources watching for outputs. That's it. And in order to even tackle the complexity even more, we wrap around the whole thing in a single abstraction. The whole supply chain is a single object, a single abstraction called cluster supply chain, and this is a blueprint, right? In Cartographer jargon, the cluster supply chain abstraction is called a blueprint, or yeah, the cluster supply chain is a type of blueprint, right? So first way to handle complexity, using abstractions. So what happens here? We have these abstractions here, and we have real world right there, the underlying platform and yeah, your Kubernetes environment. In the middle, there's the Cartographer controller or the choreographer. And what happens here? So we have the ops teams, DevOps, SecOps team, they own and apply the cluster supply chain definition. I mean, they are owners of the definition of what is the design of each one of the supply chains, right? We need workloads to complete these specific steps in order to be considered ready for production, right? So they control the steps or the resources that need to go in the actual supply chain, and they also control the level of flexibility they leave to devs. So for example, let's say I will create a supply chain that will be used for all the web applications. I will leave flexibility for devs to define the tool they want to use to build the image. I mean, for me, it's the same, but they won't be able to select the tool to perform the security scan. It will be hard-coded, right? So this is the way to apply a policy throughout all the fleet, or to standardize on a specific tool throughout all the applications. Very simple, and trying to having the best of both worlds, having control, having compliance, but also having flexibility for devs. So ops teams, they own and apply the definition of the cluster supply chain. Developer teams, they only need to submit a workload definition, and if there is a supply chain that match this workload definition, that match the labels of the workload, the controller will reconcile that into actual resources, creating or updating the necessary resources in the Kubernetes platform. That's it. That's the principles operation of Cartographer. Benefits here, well, separation of concerns. Now it's completely clear what the ops teams have to do or need to do, and even more clear what the developer teams need to do. And that's it. Also flexibility, because, well, it's way easier to swap tools, and also even with having a lot of flexibility by using the choreography pattern, still operations teams have control. Modularity, yeah, that was the word, because you could build a definition, standard definition of supply chains, and if you leave, some resources open to the definition by devs, you get the ability to swap out resources, to swap out tools for a specific step in the supply chain, and it becomes consistent even when the teams and the workloads start to grow. This remains consistent. It's very important because it's completely repeatable, right? The fact that we are using abstractions here make it repeatable. You just re-instantiate the same abstraction, and developers only need to provide the workload definition and the fields that are left for them to configure, and that's it. That makes it consistent throughout the entire environment. Right, so yeah, kind of a summary here. So resources are wrapped around the template abstraction. There are 5 types of templates in Cartographer: for source, image, configuration, deployment, and a generic template for anything else. With different combinations of these templates, we build blueprints, be it the cluster supply chain blueprint. The Cartographer project only has 2 blueprints right now. So cluster supply chain and the cluster delivery blueprint that constantly deploy and validate configuration to the Kubernetes environment. And that's it so far. What if you already have an investment in CI/CD tooling? I don't know, Jenkins, Concourse, etc. Well, Cartographer includes a CRD called Runnable that serves as a bridge, let's say, to use a more common term instead of receiving changes that will go to an immutable resource and make it kind of mutable. But yeah, it's kind of a bridge to integrate your existing Tecton, Jenkins, etc. tooling into a cluster supply chain choreographed by Cartographer. Right, so it's important here to mention that Cartographer allows you to build a platform, and Cartographer doesn't know anything about the resources or the steps in your supply chain, as we saw. It doesn't matter. It coordinates the passing of information between the resources, enabling all the advantages we just saw. So Cartographer doesn't replace any tool to build images, to scan code, to testing, nothing like that. Carto doesn't execute the actual steps. It coordinates the passing of information between them, right? So far, so good. Any questions? No? Okay.
Yeah, I have a question, Ed here. So in your cluster supply chain, I see scan source code, for example, and I'm guessing that's a resource, as you mentioned, and you mentioned resources have an input and an output. So what would be the output of scan source code?
Yeah, well, it's something that you could certainly define, but yeah, for example, that would be the actual resource of the scan, if there is a CVE found or not, path to a report. It could be, it depends on the tool you're actually using to perform security scan. It can be defined. But as long as this output, for example, the result of the security scan, I mean, a number of vulnerabilities found. As long as there is a specific type of result, the next step will continue or not.
So
I will let Sam or Emily. Maybe.
go for it, Sam.
Go ahead, Emily. You got it.
Okay. I mean, I was just saying, so in most of the examples that we have, the input we're watching is the source, and the output is also going to be that same source. And so it's mostly just like a gate to prop that up. And like David was saying, regarding CVEs, we would expect that, in the resource that gets created for scan source code, like they would update that status, their own status with the CVEs, and whatever tools you want to build on top of that to, handle those CVEs is up to you.
Cool, thanks.
And we also,
oh, go ahead.
Sorry, I'm so sorry. Just going to say, we also have recent RFCs in where we will present that output. So there's two types of output, and you're thinking of the output of a scan. The output as far as the supply chain is, just like Emily said, just the source as a gate. The output, the scan tells you. We'll also work on making sure that its status is reported up to the workload, so that the developer can quickly scan the workload for the status of resources under the hood.
Got it. So it kind of passes through the source, maybe the SHA or something along, but it's a gate.
It's in fact we usually store a table on a on cluster repository. So it's a URL typically, and a revision just so that we can reference it if we need to. So the SHA is there as well, but the main important thing is that there's an on cluster copy of the source that's been pulled from Git or whatever source SCM you're using.
Thanks. Yeah, I used to be a heavy concourse user, and definitely see the influence of the same resource idea. So very cool. Thanks.
And I think, hi everyone, my name's Sam. I'm a product manager in the Cartographer project, and this is Emily and Rosh are engineers in the project. I think, correct me if I'm wrong, folks, but I think you can also you would output the source again, so it would be the same input and the same source, but you could also provide, like in the config, you could change a value, right? So you could say something like scan passed, scan changed from like not run to passed. Is that correct?
We currently have an RC in place that is talking about like putting more status into the workload, but today, like, the output would simply be the source that, the tarball that Rash was mentioning.
Okay, got it.
Great, thank you. Yeah, I hope that answers your questions, Ed. Cool, thanks. All right, so let's move to the fun part. Let me go down here. And there's something truly exciting that I want to show you. I'm not sure if you're watching my screen or not. Nope. Yeah, well, the demo plan is to actually build a supply chain from scratch, and if time permits, to see a kind of little bit more elaborated supply chain here. So I'm really glad to share with you a new breed of tutorials that the team has developed recently that are designed to walk you through step by step from the very beginning, even from a Kubernetes cluster with no Cartographer installed, to an actual supply chain being choreographed by the project in a single page. So we definitely recommend you to follow this up and to provide your feedback. I will share with you a little bit about that. But we really encourage you to start here and to see how it looks like to ramp up with the project. So here the tutorials try to go through two roles, the app operator and the app developer, in order to have a very simple supply chain. How simple? It's just a single step. You will observe or you will watch for a pre-built image, and it will ask the Kubernetes API to create a deployment for that image. That's it. Pretty simple. Please don't think that this is the only thing that Cartographer can do. This is just for educational purposes. You will probably get the idea on how flexible is this and how to build a way more sophisticated supply chain. Right, so the first thing will be to actually build, we will use a resource or a cluster template. Remember, the template is an abstraction for resources or for steps in your supply chain. So we'll have this here. All right, so I will use this. Please just let me know if I need to do some in or something like that. But if it's fine. So pretty simple, the name of the cluster template, app deploy. And here we will have a deployment. The name must be unique. But remember that eventually we are doing what an operator will do, right? Nothing so far with the dev team, but eventually the dev team will submit a workload whose name will be unique. And it has to be unique because that's a requirement from Kubernetes for all the objects in a specific namespace. So we will leverage that behavior, that workload name, for all the fields that must be unique, right? So tutorials mention here that for all the unique fields, we will use the name field from the workload definition. Where is this workload? Well, I will show you later on. But for all that has must be unique, let me quickly replace this. We will have this be generated or obtained from the workload whenever it is submitted. Right, it's there. Everything that it's meant to be unique was replaced by a parameter, right? So this is the first important concept. We use params to allow for repeatability, for flexibility, and so on and so forth. All right. Replicas can be hard-coded. This is just an example of a field that I, as an operator, will leave hard-coded. I mean, a policy in this company is that all the deployments need to have at least three replicas running. So I will leave it hard-coded. You can change the workload name, doesn't matter, but replicas are hard-coded. It's an organizational policy, right? And finally, there's a value here, not only to the actual image they are going to use as the artifact to deploy their application. That's known only to the dev. I just certainly don't know, right? So for that, again, we will use a field that will be part of the workload spec definition, and it's basically this, right? So, using params, there you go, right? Okay. Next up, this is the template. So next thing is, well, Cartographer will need RBAC permissions to create or update our objects. So we'll have to define a service account for that. We have here an example with a set of permissions. We do the service account, the role, and the role binding. It will be basically permissions to manage deployments. I know this is a huge list of permissions. Probably your organization needs something different, but it's just an example of what is needed here, the actual service account, right? All right, I will move quickly here. Now, the supply chain. So remember, what we just defined was the only step in the supply chain, the only template, the only resource. It's a cluster template resource that won't emit any output, and we will basically take an image, we will read for an pre-built image, and that's it. It will instruct to create a deployment with a specific name, and that's it. Right. So now we will create the supply chain that will use this template, right? So the supply chain definition, well, it starts from here, but the important part that I want to call out, it's here. Resources. Resources is a list, and it's a list where the order matters. I mean, we have here only a single step that we call it deploy, and it has the reference to the actual template that we just built, the app deployed cluster template. That's the single step in the supply chain. But whenever you have more steps in your supply chain, you will complete this list, and the order will be from top to bottom, from first step to last step. There will be the steps of your supply chain, or the resources in your supply chain, right? That will be it. The reference to the service account we just created, and something that it's really important, as selector, right? So this is the way to connect with whatever the developers will submit in the workload definition. They will assign a label to it, and they're eventually matching label and selectors will meet each other, and that will trigger reconciliation of resources, right? So that field, it's important. Let me put it here real quick. There you go. All right. Okay. The supply chain, and basically that's it from the operations side. Defining the step and putting that into the supply chain abstraction. Right now for the developers, well, it's even more simple, because remember that they need to only specify the workload definition. And in this case, they will use the same, actually the same label that will match the selector we have here, right? It's a pre-built image type of application, so we will have it right here, okay? The image here is, part of the spec of the workload definition is the actual image. That remember that it will be read by the template over here. It will be read here, right? And also the name, obviously, right? Because if, okay, yeah, there was something I was about to say, but it doesn't make much sense. All right, so that's the only thing that the developer needs to submit. It will be the workload definition. Here real quick. And yeah, we will need only to apply that workload definition tutorial. And there you go. Everything is there, just create it. So there, the tutorials will walk you through on observing the results and explaining the meaning of each one of the fields here. So so if I do workload, oh yeah, so YAML. Hello. Okay, this is great. I wanted to create this error because I did something that will cause that reconciliation fails. No supply chain found where tool selector is satisfied by labels. And reason for this is that I use field called workload dash type, and here is yeah, it has a different capitalization there. It's yeah, pretty simple. Yeah, pretty simple error, and I will just fix it right away. There you go. Yeah. Okay. Let's do template. So, if there's any question so far? No.
I have a question. So, what kind of examples of organizations are using this right now? And what's kind of the target type of organization or situation where somebody would want to choose this tool and set it up?
Yeah, well, the project is very young, but right now we have, let's say, implementations of Cartographer using this in the context of, again, a platform that consumes choreography in a way that allows for faster execution of paths to production. That's such as the case of some commercial offerings from VMware who actually use consume Cartographer. I don't know if someone else from the team would like to chime in, but yeah, it's more in the context of the platform that is built on top of it to allow for faster delivery.
One of the inspirations for Cartographer is the Heroku push and the Cloud Foundry push model, which is the idea that generally developers should not have to think too much about the supply chain. They're more interested in, I've got an application that works here. It should work in prod. I don't have to define much. So in the workload, you see that there's very little specified as far as a developer is concerned. They're a little bit light in these examples, but they tend to also include some information about service bindings you might want to attach to, but generally still very lightweight. And so the kind of enterprise or business that wants to involve itself with this kind of solution is anyone where they still need to control path to production. They need to make sure that important compliance is met, important security and patching rules are met, and that they can specify all of those in the supply chain without making it the developer's problem, and still enable the developer to quickly iterate and release to prod. And so there's quite a lot of them who want to have that. So everything Cartographer could do could be done with a Tecton pipeline or with Concourse or something else. But its approaches to try to drill home a design and to aid with that design that makes developers care about just what they care about, nothing too deep unless necessary. You know, I mean, sometimes you need to break edges and break glass, but in most cases you want a fairly consistent and straightforward path to production as a developer. I hope that helps a bit.
So I know that Concourse is another big project inside of VMware. Like, are you folks collaborating directly or indirectly to kind of cover separate territory and have strategic integration, or is it really like first past the post, or serving different demographics or different use cases?
These are quite different demographics, and one of our constraints is that we use Cartographer's design is not to be a CI/CD tool. It is a tool to do continuous deployment using CI/CD tools and scanning tools under the hood. And unfortunately, Concourse doesn't have a version of itself that is a K8s resource, whereas there is Tecton. So that's typically what we use as examples for when you want to integrate some CI/CD. Or you can come out of your concourse CI step and then move into a supply chain for the rest of the delivery. So they have different needs, and one of the requirements of Cartographer is that there is some way that you can adapt your existing systems to work as resources in a Kubernetes namespace.
Yeah, thank you. Yeah, well, not sure what happened, but it's failing on my side, but it will basically be this, the results will be not only that the supply chain is ready, but, you know, most importantly, that resource submission was completed. I mean, every resource definition that we configured here in the supply chain was successfully submitted. Probably some resources are still reconciling, but the submission was successfully completed. And yeah, and so on and so forth. In this case, the stamped object, right, which is a Kubernetes deployment, right? There's additional examples that you could explore here. Let me put it in the chat. That starts from the what we call a basic supply chain that, well, it has at least 3 steps. A resource watching for changes in the source code, resource building a container image out of it, and then finally deploying to Knative serving. Right. So here, what is different, you will see that there's, let me share it with you here. Yeah. So what's different here is compared to the very basic example we were just looking at, is that we have from the app operator, we have the definition of the 3 templates, 3 resources, 3 steps. So here, for example, for the first step, we're using FluxCD and the Git repository resource that will pull a repo every minute, and it will produce a specific type of output. Which output? This one. So here we are instructing the resource, and eventually Cartographer will read this and will know, okay, these are the outputs that we will be watching, right? The URL and yeah, the URL path and the revision for the artifact that is downloaded from the repo, right? This is the first step. The second step will be the second resource will be one that actually builds a container image out of it, and it will emit an output that says, hey, the image is there in this path, right? And for this specific case, we're using KPack. But again, as long as you're using, your tool is emitting this type of output, you could use a different tool, completely different, right? And as well, considering that the ops teams leave you the ability to use a different tool. And finally, the app deploy. In this case, we are using CAP controller, part of Carvel Tools project, to actually deploy an application from the image produced in the previous step. So if you see all these YAML, you probably notice that all these steps are completely disconnected from each other. We still need an abstraction that to wrap this up and actually connect it. So here is what an app operator will do. It will basically create the supply chain, right? Again, the same definition as selector, right? Really important. And look here. Here are the list of resources that we will use in the specific supply chain, the order of the steps, cluster source template, watching changes for the source from the source code, an image builder, and finally what we call a deployer or a cluster template that will actually coordinate the deployment of the application and the Knative serving. Right? All of that is from the ops side, right? And again, the developer will only need to submit the workload definition using the same selector in this case. And here, it will provide the location of the source code. It's different from the introductory supply chain where the image is pre-built. Here, it will be the path where the code is, and all the process will be triggered from that point on. So it's only necessary to submit those files to the controller, and reconciler will happen right away. Right, so I just wanted to know if there's any other question here so far.
Yeah, I had a quick question. Is there a UI to kind of visualize all the workload runs or historical runs instead of querying Kubernetes?
And what can we say, team? Well, native to the project, I would say not yet. We could use different tools to do that. But yeah, I will let the team chime in to probably give a better answer on that.
We don't have anything on the roadmap for that yet, I don't think. Sam, you answer. You're the.
It doesn't exist today, but it would be a great issue to raise if you're interested, and we can learn more about what you're thinking. Do you have an example of a system like that today that you feel like works really well?
Just more from like a maybe auditing thing, like just to see when like a commit went through and going through a historical like build, deploy, security scan, like auditing purposes, and seeing like the jobs that actually ran. But yeah, just hypothetical.
I'd imagine that that's a pretty common use case for a lot of apps that live on top of Kubernetes, right? I mean, the essential pattern is like query Kubernetes logs with a filter, and then visualize the response. And I imagine that everything on top of Kubernetes has like a similar use case, right? To have something that's a little bit more friendly than command line, or a little bit more interactive. But essentially, I mean, you could do the same thing with like directly with like Postman or whatever, right?
There is a conversation in the open source channel where someone's talked about this very recently, the Cartographer OSS channel. And internally we have goals for this already, but there's no reason there can't be external tools as well. But what it does mean is that we are investing a lot of effort in making sure that the right information is available from Cartographer, and that we can make that stuff accessible more readily from something like Backstage, right? Or one of those kinds of tools. So that's where our current focus is on. So I know that at least, in terms of UX, we're actually looking at making the workload even more informative. There's an RFC for workload status, and there is also one for events, where we're planning on putting events on workloads and probably on supply chains too, so you can get operator views of how supply chains are behaving with workloads. But I would ask that people submit their requirements or expectations as issues. It'd be great. We'll talk about it in the open source channel too.
All right, we are officially past 6, so I'll take one more question. David's been very generous with his time. And I know a lot of folks probably have dinner plans, especially here. So does anybody have one last question? All right, I'll ask a question to the whole team. What's the item on the roadmap for Cartographer that you're most excited about?
Right
Mine's
now, I would
artifact-
say,
Go ahead.
I would say
Sorry,
right
go,
now, I
Emily.
think it's status on the workload, like just getting as much information to the use, like, to the dev or to the users as that we can. And we've talked about it many times, so we're excited about that.
And one that worries me, but we definitely need to tackle is artifact tracing. And so that's important to me too. That whole idea of auditing becomes problematic when you are working with resources, but that don't have to tell you whether their input matches their output, not over time anyway. So that one's going to be very interesting. But I'd love to get that resolved because I know a lot of people care.
David,
Great
I
question.
might have jumped the gun. I know you had a wrap up slide. Feel free to sort of cover anything that you want to wrap up, and then we'll let you off the hook.
Yeah, no, it was just a couple of things. First, to invite anyone here to continue the conversation. We have several ways to collaborate, be it synchronously in meetings, community meetings, office hours, where we discuss RFCs, all these ideas to improve the project, and also several asynchronous collaboration channels that you can see there. That's first thing. And second thing, we are right now actually collecting feedback for the work you saw on tutorials and documentation. Please check out docs and tutorials. And if you want to separate some minutes from your time to have a conversation with us, providing your brutal or honest raw feedback with us, that will be really helpful. And in exchange for your time, we will provide you with a nice bundle of swag, sustainable swag shipped to your home. So yeah, feel free to check out tutorials, docs, sign up for the feedback loop there. And yeah, really glad to be here to have your input. It was really useful.
Thank you. This was really interesting. I love hearing about these projects that are trying to bring a little bit more rigor and consistency and structure to workflow. I'm currently working on a value stream management standard to try and establish some of this, like bill of materials and definition and auditing to workflow, like the human interaction part of all this stuff that gets automated. And so I think that there's going to be a lot of kind of intersection and overlap across all these different projects where we're at the state in the industry now where you know, software is running the most critical aspects of the world. It's, you know, it's clearly vulnerable all over the place, and that's a very dangerous state for the most part, potentially. So I think that the more we can add this level of visibility and traceability and definition and standard and make it easy for people and easy to integrate into the sort of tooling that we're used to and the patterns that we're used to, hopefully so that it just does what it does behind the scenes and we don't have to worry about it all the time. That's really cool. So thank you, David, for joining us. Really appreciate the time. I am going to share one last slide to let everybody know about next month. So next month we have Benjamin joining us to talk about Scrum and Azure DevOps. And this is something that I've been bumping into in a lot of teams. Obviously it's very close to my heart when it's talking about workflow. So excited for that. Join us next month. Thank you everybody from the Cartographer team for joining us. I love when we have a whole team available to answer questions and be engaged. So I really appreciate that. And thank you to everyone. Hope you have a wonderful evening or rest of the day. And we'll see you next month.
Yo.